All right, guys. Now that we know a little bit more about sine and cosine of angles, I'm just going to mess around a little bit here and show you a couple cool things that'll be very useful when finding sine and cosine of different angles. So right here we have an angle that can move around, right? Now, we've been really trying to drive in the fact that the sine of this angle right here, let's call this angle theta, the sine is simply this height right here as long as this radius equals 1. Okay, what happens if the radius isn't 1 though? What happens if the radius is 3? Okay, well now this obviously will no longer be the sine of the angle because it's broken up into 3 pieces. Right here the radius is 1. This is a sine of that angle. Well, what is this compared to this? Well, this is just 3 times as big. So this is equal to 3 times the sine of the angle. All right, so it's always this hypotenuse times the sine of this angle will be the height. So this will be, this point right here will be 3 times the cos of the angle, and this will be 3 times the sine of the angle. Right? Because this right here, this is the cos of the angle right here if there's a radius of 1, but since there's a radius of 3, then it's going to be 3 times that. Okay, so the distance to the right is 3 times the cos of theta. The distance to upward is 3 times the sine of theta. So basically what I'm saying is it's just r times the cos of theta, whatever distance r is, and r times the sine of theta. Okay, and so we can say that the sine of theta is just this divided by r. Right? So it's whatever the height is at the end of your angle divided by the actual radius, which will give you this height right here, divided by 3, which will give you that height, which we know is a sine of theta. Okay. Basically, I just went over SOHCAHTOA with you guys. Right? So basically I just said, hey, look, if you take this height, this is a sine only if this is a radius of 1, but if the radius is different, you have to divide by it. Okay, well, that's basically we're saying it's this height, which is your opposite side, divided by whatever the radius is, which is your hypotenuse. Opposite over hypotenuse. Okay, so let's remember that. Sine of theta is opposite over hypotenuse, and cosine of theta is just going to be adjacent over hypotenuse. I know this is something you guys already knew. I just wanted to kind of make you think of it in a different way so that when you're talking, when you're on the Cartesian plane and you have a point and you know this angle, then you just know that that point is always r cos theta, comma, r sine theta. And if it happens to lie right on the unit circle, well, then this will just be cos theta sine theta. Okay, if it doesn't lie on the unit circle, well, you just have to find how far apart it is, how far it is from the origin, and multiply both the coordinates by that. All right, so I'm just going to pick some random, some random angle here. Let's say about that far there. We'll just call this angle alpha. And then I'm going to actually make another angle above it right here. We're going to call that angle beta. Okay, I'm going to draw a line straight down from the edge here. I'm going to extend this line out a little bit. It'll make it easier. Okay, from here I'm also going to draw another line at a 90-degree angle to this right here. So I'm going to make this red. Let's say from here, I'm going to make it a 90-degree angle here. I'm going to draw another line straight down from this point there And I'm going to draw a line across, straight across here. Alright, so you got a bunch of cute lines. There you got a rectangle in this area. These are all 90-degree angles. Alright, I'm just going to extend this line out a little bit just to kind of show you. Alright, that's just to show you that this blue line here and this line down here are parallel, and this is the same line. So obviously this angle right here is also alpha, same angle, right? And so that means that this angle right here is also alpha, right? Because these are just these two lines forming an X pattern, so this is alpha as well. All right, well, since I drew this as a 90-degree angle, this red line to the black line is a 90-degree angle, well, then that means that this right here, this angle plus alpha equals 90, but also this angle plus this angle equals 90. Well, if this angle here plus this guy, alpha, equals 90, and this guy plus this guy also equals 90, well, then that means this must be also equal to alpha. There's only one angle that could add up to this to give 90. So we know this is alpha, and this is alpha. Okay, I'm going to start color coding these lines just to make it nicer for us. All right, let's call this line segment A. We're going to make it green. Okay, this line segment here we're going to make purple. We'll call that B. Okay, for C we'll do this side right here. We'll make it blue. So C. Okay, we got three more. We got this one right here. We're going to do in an orange. You probably guessed I was going to call that D. Alright, let's make this little guy black here. Predictably, we're going to call that E. And the last one, we're going to start at the top here, and instead of just going down to here like the black one, we're going to go all the way down. So I'm just going to kind of put it next to it so that you can see the black line and the pink line kind of. So the pink line covers where the black line is. But also we need to remember that that black line is still there. Okay, so you still have the pink line here going all the way down to the bottom, but you still have this little black line in area in there. All right, and the pink we're going to call F. There we go. All right, there are some things we already know. Okay, we know that the sine of alpha equals this opposite line over the hypotenuse, right? This is alpha here, so sine of alpha is opposite over hypotenuse. So we can actually say sine of alpha is this red line, so D, or the orange line, sorry, D, over this purple line, which is B. All right, next we're going to talk about the cosine of beta. All right, so now we're going to focus our attention on this is beta right here. And so the cosine is going to be the adjacent over the hypotenuse of this triangle. All right, so the adjacent is this purple line, and the hypotenuse is the green line. So cos of beta equal to adjacent, which is the purple line, as I said, over the green line, which is A. I'm having a rough time here. It's kind of neat that it went like that, because if you notice there's a B on the bottom here and there's a B on the top here. So there's something cool. If you were to ever multiply sine of alpha times the cos of beta, that would reduce really nicely. It'd be D over B times B over A. The B's would cancel and you would just simply get a D divided by A. Now, if you remember, I specifically made sure that you guys saw that this alpha angle and this alpha angle have to be the same if I were to make this this blue line a 90-degree angle. Okay, that's really important for this next step, right? Because we know that the cosine of alpha is equal to, well, in this triangle, this is the hypotenuse and this is the adjacent. So it's going to be the black line, E, is the adjacent side, divided by the blue line, which is the hypotenuse of that. There you go. Now we haven't done sine beta yet. Let's try sine of beta. Okay, well, where's beta? Here's beta right here. So the sine of beta is opposite, which is this blue line again. That's curious. So we're going to do opposite, which is C, divided by hypotenuse. And the hypotenuse is this line right here, the green line. So A. And similarly to what we did before, we can actually multiply these two together. We can say cos of alpha times the sine of beta, and that works out nicely too. Well, we have, this is going to be E over C times C over A. Well, if you multiply those together, you're going to have a C in the numerator and in the denominator that are going to cancel. You're just going to get E divided by A. E divided by A. Okay, I'm going to do something that might seem strange to you guys, but I'm actually going to add these two together just to see what I get. I'm going to get sine of alpha times the cos of beta. So sine of one angle times the cos of the other, plus the sine of the other times the cos of the first one. So sine alpha cos beta plus sine beta cos alpha. And that is going to equal, well, it's going to be D over A plus E over A. Okay? Or we can just write that as D plus E over A. But wait a second, what is D plus E? That's this red line. Let me see, this is red line, D plus E is just this red line plus this black line. Well, isn't the red line plus this black line, isn't that just the pink line? Yeah, so we can actually say that this is equal to D plus E is just equal to F. F over A. All right, there's one more thing I want you to see. What if I did the sine of this whole angle, A plus B, like the sine of this large angle here? What would that equal? Well, that would equal, sine is just going to be the opposite, so it's this pink line here. this opposite over the hypotenuse. So the pink over the green. So that would be equal to pink, which is F, divided by the green, which is A, F over A. But wait a minute, isn't that what we just said? Sine alpha cos beta plus sine beta cos alpha equals? It is. So we can actually say that in conclusion, we can say that sine of any alpha plus beta is equal to the sine of, so if I have this big angle, I could split it into two, and I could just rewrite it as sine of the first one times the cos of the second one plus the cos of the first one times the sine of the second one. There you have it. How is that useful to us? Well, there are a bunch of ways you can play around with that. So we know a lot of our special triangles. We know that sine of pi by 3 is equal to root 3 over 2. We know that the sine of pi by 6 is equal to 1/2. We know that the sine of pi by 4 equals 1 over root 2. Those are all nice to memorize. But what if we wanted something like, so just keep it, just for you guys, because I know you're still starting with radians, just kind of keep in mind this is 60 degrees. That might make it easier for you guys. 30 degrees. I don't know when I should stop kind of babying you with that, but I think it's important to kind of keep it in your head. So sine of 45 degrees is actually sine of pi by 4. Okay, so what if I wanted the sine of something like 75 degrees? That's going to be the sine of, so let's say, so I know the sine of 15 degrees is pi by 12, so it's going to be like sine of 5 pi by 12. What does that equal exactly? Well, we don't know that one by heart, but we do know that the sine of any like any compound angle, this is just the same as sine of 45 degrees is pi by 4 plus the 30 degrees is pi by 6. You can kind of verify that. Pi by 4 is the same as 3 pi by 12, and pi by 6 is the same as 2 pi by 12. That is equal to 5 pi by 12. Okay, so I could have written 3 pi by 12 and 2 pi by 12 here, but I think this is nicer because we recognize it. And now we know that the sine of any angle plus another angle, the two together, two combined, are equal to the sine of the first one times the cosine of the second one plus the sine of the second one times the cosine of the first one. Doesn't matter which one's first and second, by the way, as long as you have sine of one and times cos of the other, and then switch them there. Well, I know that the sine of pi by 4 is 1 over root 2. I know the sine of pi by 6 is 1/2. I know that the sine, or sorry, the cos of pi by 6, oh, we better back up there. Yeah, so I should have mentioned, so I gave you the sine of pi by 3, sine of pi by 6, sine of pi by 4. I should also have given you the cos of pi by 4, we know is also 1 over root 2, and the cosine of pi by 6, we know is root 3 over 2, and the cosine of pi by 3, we know is 1/2. Okay, so we got a little mistake here. Cos of pi by 6 is root 3 over 2. That feels better. Root 3 over 2. Okay, plus the sine of pi by 6, which is 1/2, times the cosine of pi by 4, which is 1 over root 2. And that just equals, we'll multiply them out, you got root 3 over 2 by 2, 2 root 2, sorry, plus 1 over 2 root 2, which equals root 3 plus 1 over 2 root 2. Right, some people hate to see roots on the bottom, so I'm going to continue along and say I'm going to multiply top and bottom by root 2. So root 3 times root 2 is root 6, plus 1 times root 2 is root 2, all over 2 times, well, root 2 times root 2 is just 2, so this is over 4. And that is the exact value of sine 5 pi by 12. What if I wanted the sine of, let's say we wanted the sine of pi by 12. What if we wanted to do that? So let's say sine pi by 12, that's, you guys might still be thinking 15 degrees, but you shouldn't. Sine pi by 12. Well, we could just say that that is the sine of pi by 4 minus pi by 6, because pi by 4 is the same as 3 pi by 12, minus pi by 6, which is 2 pi by 12, is just equal to pi by 12. Okay, and so this is actually the same as saying sine of pi by 4 plus negative pi by 6. Okay, well, we know negative pi by 6. Here's our unit circle, negative pi by 6. Well, the sine of negative pi by 6 is just negative 1/2. And the cosine of negative pi by 6 is still positive 3 root 3 over 2. Okay, because we know that negative pi by 6 goes downward, and so the sine has to be negative because it's under the x-axis. But the cosine is still positive because you're still to the right of the x-axis. Okay, so we're going to say this is equal to sine of pi by 4 times cosine of negative pi by 6 plus cosine of pi by 4 times the sine of negative pi by 6. All right, well, sine of pi by 4 is 1 over root 2. The cos of negative pi by 6 is root 3 over 2 plus the sine of pi by 4, or cos of pi by 4, 1 over root 2, and the sine of negative is times negative 1/2 of negative pi by 6, negative 1/2. Right, and that is just equal to root 3 over 2 root 2 minus 1 over 2 root 2, which equals root 3 minus 1 over 2 root 2. And of course, a lot of people like to get the root 2 out of there. So we're going to say root 6 minus root 2 over 4. There you have it, compound angles. All right, we're still going to go, there's still a few extra things that we can do that relates to that. So sometimes you're asked about things like double angles, something like sine of 2x, okay? Well, since we know that this is the same as sine of x plus x, well then shouldn't that just be equal to sine, cos x sine, so cos of the first one times sine of the second one plus cos of the second one times sine of the first one. Well, since the first one and the second one are the same, well, this term and this term end up just being the same thing. This is just equal to 2 cos x sine x, or 2 sine x. For some reason I wrote cos before sine, which is not normal, but 2 sine x cos x. So sine of any 2x is 2 sine x cos x. So that's just a special case of our compound angles for sine. Let's just try some that we already know. Do you guys, if you remember that the sine of 2 pi by 3 should equal, let's see, 2 pi by 3 is up here, so it should be root 3 over 2. And the cosine is negative 1/2. And half of that is pi by 3. The sine of pi by 3 is also root 3 over 2. But the cosine is 1/2, positive 1/2. Right, so let's say sine of root 2 pi by 3 is just equal to sine of pi by 3 plus pi by 3, which equals the sine. We know all these answers, right? We already know the answer here is going to be root 3 over 2. Well, let's just kind of see how our formula works. So sine of pi by 3 cos of the second one, pi by 3, plus sine of the second one, pi by 3, times the cos of the first one, pi by 3. So it's just 2 of those. Well, sine of pi by 3 is right here, just root 3 over 2. It's the same as sine of 2 pi by 3, but cos of pi by 3 is 1/2, so times 1/2, plus the sine of pi by 3, root 3 over 2, cos of pi by 3, 1/2, which equals root 3 over 4, plus root 3 over 4, which equals 2 root 3 over 4, which equals root 3 over 2, which is exactly what we thought. Okay, so we're just kind of testing a few. There's another one that's fun is what about the sine of pi by 2? Sine of pi by 2 should just be straight up. This should just equal 1. Right? Sine of pi by 2 equals 1. We also remember that the sine of pi by 4 equals 1 over root 2, and the cosine of pi by 4 equals 1 over root 2. So let's test this out. This is just going to be the sine of pi by 4 plus pi by 4, which equals, or we can say the sine of 2 times pi by 4. So this is a double angle formula, so we could just say that this is 2 sine of pi by 4 cos of pi by 4. Okay, we're using this new equation that we built from our compound equation, so our double angle formula. Right, and that's just going to equal that. Let me get rid of that big dot I made. Okay, so that's just going to equal 2 sine of pi by 4, which is 1 over root 2, cos of pi by 4, which is 1 over root 2, which equals 2 over root 2 times root 2 is 2, which is just equal 1, which we already knew. Okay, that's just to confirm. All right, just reading your mind a little bit, you're saying, oh, that's wonderful if I do have the sine of 5 pi by 12. I know I can convert this to sine of pi by 4, which is 3 pi by 12, plus 2 pi by 12, which is pi by 6. Oops. Pi by 4 plus 2 pi by 12, which is pi by 6. And then I could just use since I know these by heart, I could just use my compound angle. But what happens if I have the cosine of 5 pi by 12? Does it work as well? Well, sort of. Let's just go back to way before. I just have to add one more color. I'm going to add a letter G as well. All right, so let's call this, I need another nice color here. All right, let's get a nice brown, and we're going to call this line right here, I'm going to call that G. It's a line we never really used before. All right, so we're going to call that G. Go right there, rip it there. And we're going to say, okay, so what is the cosine? Let's just go through all the things we went through before here. I'm going to do it in a better color this time. So let's say, what is the, oops, not sine. What is the cosine of alpha? Okay, so where's it? This is alpha here. So the cosine of alpha is this bottom line here, this black line here. I'm going to make that. Right here. Oh, we didn't call that anything last time either, did we? All right, so let's make that black one. We'll call that E this time, but it's going to be, yeah, let's do a different letter just so there's no confusion. Let's call this H. All right, there we're going to call that H there. Okay, so we're going to say that the cosine of alpha is adjacent over hypotenuse. It's going to be H. I'm just going to remember that that's H there. H divided by the purple one, which is B. We're just going to do that. Just keep the B there so that nobody forgets, over B. All right, let me say the cosine of alpha. No, that's alpha. Cosine of beta. Let's try the cosine of beta. Cosine of beta, now we're just looking at this triangle right here. So the cosine of beta is equal to the purple B over this green. Let me erase this so it actually looks green. Over the green. Which is A. So we said B divided by A. Alright, so cosine of beta, oh, I lost that beta. So the cosine of beta is this B over A. Alright, let's try sine of alpha. Sine of alpha, okay, don't forget that this is alpha in here as well. We went through some work to make sure that everybody knew that that angle here is equal to this angle here. So sine of alpha is this line right here, which is our brown line. We called that G. That's opposite over the hypotenuse, which is this blue line, this C. Okay, remember this is C here. Remember that this is G right here. And so it's G over C. And we have the cosine, oh no, the sine of beta is equal to, well, we're going to use this big triangle here, and it is equal to opposite over hypotenuse, so C divided by A. Green line there. All right, that's a lot of that. So let's put that all together. We know now we can see that cos of alpha times cos of beta is equal to H over B times B over A. The B's will cancel, so it's just H over A. H over A. All right, we also have sine of alpha, sine of beta which equals, well, that's G over C times C over A. Well, the C's cancel, and you're going to get G over A. That's fair. G divided by A. Oh, they're both over A, so we're going to combine these two. We're going to combine this and this. I'm actually going to subtract them. I'm going to say cos of alpha, cos of beta, minus sine alpha, sine of beta must be equal to H over A minus G over A, which just equals H minus G over A. Well, guess what? H minus G. Well, this length right here is H. And this length, this brown one right here, is G. So H minus G is this length minus this length. Well, we're just left with this length in here. And A is this length right here. So this divided by this is exactly the cosine. It's the adjacent over the hypotenuse of this huge angle. So this is exactly equal to the cosine of alpha plus beta. All right, so now we have another, if we have a cosine, say the cosine of 5 pi by 12, we can now say that that's just equal to the cosine of pi by 4, which is 3 pi by 12, plus pi by 6, which is 2 pi by 12, and that is equal to, so the cosine of one angle plus another angle is equal to, right here, this is equal to this. So it's equal to the cosine of the first one, cos of pi by 4, times the cosine of the second one, cos of pi by 6, minus the sine of the first one, times the sine of the second one. And that, we know the cos of pi by 4 is 1 over root 2. We know the cosine of pi by 6 is root 3 over 2. We know that the sine of pi by 4 is 1 over root 2. And the sine of pi by 6 is 1/2. So that equals root 3 over 2 root 2 minus 1 over 2 root 2, which equals root 3 minus 1 over 2 root 2. And unfortunately, people hate having roots in the bottom, so we're going to multiply top and bottom by root 2. You're going to get root 6 minus root 2 over 4. There you have it. All right, so what did we learn? Let's look at that. From that triangle we learned, or from those triangles, from those sets of triangles, we learned that the sine of any two angles added together is just going to equal the sine of the first times the cos of the second plus the cos of the first times the sine of the second. The cosine of any two angles is just going to equal the cos of the first times the cos of the second minus the sine of the first times the sine of the second. Right? And you could derive double angle formulas from that. You could say that the sine of any double angle, so let's just call it 2x here, is just equal to what's going to be the sine of x cos of x plus cos of x sine of x. So it's just going to be 2 times sine x cos x. All right, and the same thing. Well, what if we do cos of 2x? Well, that's just going to be, I'm going to do over the side here, so it's going to be cos x minus sine x sine x. So that's just going to be equal to cos squared x minus sine squared x. So cos x times cos x minus sine x times sine x. All right, and you could just use those to derive, like you can even say sine of alpha minus beta, like sine of any angle minus the other. Well, that's just going to be equal to the sine of alpha plus negative beta, which is going to be, let's see, the sine of alpha times the cos of negative beta. But, well, what's the cos of negative beta? Well, the cosine of an angle going this way or this way is going to be the same. Cos of negative 3 is the same as cos of positive 3. It doesn't make a difference, because whether you go this way on the curve or that way on the curve, the distance to the right is going to stay the same for both. If you look at the cosine curve, it starts up here. It is an even function. So anything to the right will have the same answer as to the left. Okay, so I could write cos of negative b, but I could just write cos of b as well, because it's going to be the exact same value. Right? And then so we're going to say that's going to be plus the cos of alpha times the sine. Now I'm going to say the sine of negative beta, but honestly, if you look at a negative sign, the sign goes, sign goes this way, it's positive, and then positive, and then negative, and then negative. If you go the other way, it goes negative, negative, positive, positive. So it's just going to be the opposite. So it's just going to be sine of negative. This is going to be negative sine of beta, right? So it's going to be that times negative 1. So that we could just write as sine alpha cos beta minus cos alpha sine beta. Right, so you could just keep deriving from, let's see, let's get this out of here. So that's just going to be sine alpha cos beta minus cos alpha sine beta. And you could do a similar thing for cos of alpha minus beta. I'll let you work that one out. It'll be a nice, interesting thing for you guys to try. All right, guys. So I hope you like that. Now, we're never going to ask you to reproduce this proof. Now, if you want to be the best mathematician you can be, if you're planning on going on in math, I think it's an important thing to be able to sort of do. But otherwise, most people who do math that I know of, they just kind of look up these formulas, and whenever they get a formula, like whenever they have anything about sine of 2x, they just look it up and they say, oh, that's 2 sine x cos x. Whenever they get something with cos of 2x, they just look it up, cos squared x minus sine squared x. All right, I hope you guys liked that video, and I will talk to you again soon.